So this is Modelshop. As you can see, Modelshop is a web-based application. It can be hosted on-prem or in the cloud, either by a customer or by us. AWS, Azure, whatever the cloud provider is of your choice. Um, you can host multiple models on a single instance, and they can be shared across users with permissioning and authorization, and it's secure in that regard. What we're going to do today is build a model that is meant to refinance student loans. So we're going to start pretty much from scratch first. And the only thing I've done so far is I've seeded this model with some consumer credit information, some credit reports, which are obviously very important to making lending decisions. So let's actually take a look at that first. So here we have a credit report. We've pulled out a little bit of information, but it's sparsely populated. Obviously, we're going to need more information from the credit report than this. So how do we go ahead and add those variables and start to add our custom logic? In Modelshop, it's really easy to do. We can add a brand new field. Let's pull out the FICO first, and we'll do a couple different credit variables here so that you can see how it's done. When we pull out the detail, we're actually zooming into the scope of the particular record that we're on. And I'm going to go down in the subject record. And anybody who's ever dealt with a credit report knows it's a large, cumbersome document, and pulling things out is pretty difficult. So I would suggest you be armed with the bureau documentation. But once you know where you're looking, you can see it's pretty easy to go and find these things. They're pretty well named. This is what we're looking for. We're looking for the credit score. And once we've located it, all we have to do is just pull it out and put it in our calculation. I'm going to make this an integer. And once we save that, now we have our new FICO score that's been added to our model. We do have an error on 1 because it's missing. We can clean that up, but I won't worry about it right now. But it's not only about mapping data out of the credit report. We can also build derivative calculations on it using our own logic as well as the information contained in the report. So let's build one like that. Let's just do a simple one. So I'm going to do the number of open, if I could spell, trade lines. That's going to be an integer as well because it's just a count. And then what we can do is we can say, okay, go into my trade lines. You see we have code hints. Let's count the ones that are open. And now once we save that, once again, we see our new calculation is added to the model for all the records. And we can interact with it really easily. We can sort it. We can go in and we can filter it down, say only show me the ones with 1. So really easy to interact with the data as well as add new credit variables. So that is just one piece. We're not just trying to build a credit variable model. We want to merge it with our application data. So how do we bring in new data into Modelshop? One way is to import it. And we have multiple options. We can import from files, from databases, from web services. So in a real production environment, this may be coming from a database. Or everything you're seeing here is actually wrapped in a REST API. We'll touch on this in a bit in the future. So you can send new information in through a REST API as well. But for now, let's use some data that we have in an Excel file to build our application. So this is an Excel file with 2 tabs. We have application and program. We have a lot of different configuration options here in case the data is not clean. But right now, the defaults are looking just fine. So I'm going to load it in. And once that's done, now it adds 2 new tables, or what we call data lists, to our application. So we can switch through and look at it. It's the exact same format that we just looked at for the credit report. But now how do we actually create links between the application and the credit report itself? To do that, we can use the link wizard, which makes this task really easy. Once again, we could go and configure this by hand and say, I want to connect my application to my credit report, but it's actually gone in and detected this for us. So it's really easy to to do out of the box. It's saying you have a customer ID in both our application and credit report. One thing to note, it's not just looking for the same header, it's actually looking at the data itself. But let's take that suggestion, link it up, and then when I click done, now we have this field is now blue, which notes that it is a link field. So what does that do for us? Well, it's exactly what we were hoping. We can now insert a new field, and let's say I want to bring in that FICO score onto our application. So we can do integer, and now what I can do is I can say, for my customer ID, same code hints, I want their FICO. And I'll save the model. And now it's mapped in the FICO score from the credit report for each one of these applicants. Additionally, just like we weren't limited to extracting variables from the credit report, we're not limited to just extracting information here. We can use anything in calculations, and we can actually traverse the model all the way through more links. So just to prove this point, let's add something that we've never seen before. Let's do a total balance of mortgages. So this isn't just a count this time. Now we want a currency because it's going to be a monetary amount. And we can go into our credit report. We can go into our trade lines. Now we want to find all that are a mortgage. And then we can sum. Oops, I used the wrong function. Find returns one, find all will return everything. It's current balance. So it's that easy. We just went into our credit report, into our trade lines, we queried it down to find only the ones that are mortgages, and then we summed up the current balance. Let's actually just make it total balance of open mortgages, and then we can actually add another piece of criteria here saying, is it open? But once now we save that, now that new field is added in as well. And once again, we can sort through, filter, and look at all this information. Now we could continue to configure this, pull in all of our credit variables, link this up to programs, make offers, but that might get a little bit long. We could do so in probably about an hour. So what I'd like to do is switch forward to a version of this model that we have done just that. We spent an hour or so in there configuring things, and now I want to walk you through how we did that. So here we are in the more complete model, and you'll see that the first thing you'll notice is we now have a dashboard, an interactive dashboard, where we can change our user, and we can see all 10 offers that we're actually creating for them. So we'll take a look at how we're creating these 10 offers in a moment. But then each one of these offers has a rate, a loan amount, which is the same across. We have a monthly payment, a term. We're actually doing some predictions, which once again we'll touch on in a moment. And then we're decisioning the loan. We're saying whether it's approved or not, and in the event that it is not, we're providing reasons or a reason why. So this is actually an interactive dashboard. It's not just showing us information. We can go in and change things and see them update on the fly to try to gain an understanding of what's going on and really interact with our model. So let's take a look at how we are building this. Number one, let's take a look at our credit report once again. So we've actually expanded this out a bit. You'll see that we now have a number of trades. We've made a lot of variables that are relevant to the task at hand. So we have our student loan balance, our student loan payments. These are really important because, as I mentioned before, we're doing a refinancing model. So our initial loan amount for an application is going to be based on the student loan balance, because they may have numerous ones. As we can see, this person has 23 open student loans. They may want to reconsolidate those into one loan. So we'll allow them to do that. So we'll use this as our initial loan amount. We also have the payment, so we understand how their new payment will be compared to their previous situation. And then we've pulled out, when they've been in the file since, their history, and FICO score. So we've pulled out all this information about our users. Now, how are we going and actually using it? We'll go forward and look at our application data. Once again, very similar to what we saw before. However, this information has been supplemented as well. We've brought in the student loan balance by mapping it in from our credit report. But then we've also created information about the school itself. So this would be sent in from the user, but what we've done is we've actually supplemented this information with data from a public API that has data regarding, number one, the rank of a given school based on its academic credentials, and as well as a estimate for how much people who graduate, or how much alumni from those institutions make per year. And we can use that additional information to make more targeted and relevant decisions. So back over our application table, we've done just that. We now have our school, and we've mapped in two custom variables. Number one, we're just pulling in the mid-career median pay for each one of these institutions. But we've also created a derived variable, and I'll open it up, which is just assigning a school class based on the rank. So top 25 gets 1, 25 to 100 gets 2, and so on and so forth. So what are we using these things for? That's actually where it comes in terms of this term prediction. So what we're doing here is we don't want to just render offers based on, let's say, the economic viability of an offer, because that is subjective. It may be different to different people. Some people may want to pay off their loans faster and don't mind paying more per month. Other people may want to lower their monthly payment and try to have more disposable income or more income towards necessities. So based on people's demographics, the amount of money they make, how old they are, they may have different preferences. So this term prediction and type prediction is an attempt to figure that information out. So what we did is we created some fabricated historical training data. So these would be real life events that we've seen in the past where, let's say, a 39-year-old with a low FICO score came and a low income came in, and this is the term that they selected with a fixed rate. So we can use people who are similar to our applicants to try to figure out where their preferences might lie. And that would give us another data point in terms of how we're prioritizing offers that we're showing people, and could even impact our pricing. So the way that we did that is we trained 2 machine learning algorithms. So we're bringing in machine learning and artificial intelligence into this loan making process. So to do that, in Modelshop, it's very simple. We create what's called a new analytic. We can point to the data that we want to use. In this case, we're using our historical training data. We choose the fields that we believe are, number one, we want to predict. So in this instance, it's our term selection. And then what we believe will be predictive. So we created this data set and thought that all these items would be predictive. So essentially the loan balance, their payments, their school class, age, FICO, and income. And then we can simply press train model. It sends it up to an integration that we have with h2o.ai, which does all the data prep for us, trains the model, and comes back with, number one, what variables were most important in predicting the term that people would choose. So we can see that student loan balance and payments were the highest weighted importance. Then we also get some metrics about the training and the predictive model, seeing how accurate it is. And then I get a confusion matrix that gives us a little bit more of a visual representation of that. So we can see how many times we predicted something and how often we were correct, and how far off we were. So we get all this information, but then most importantly is we get a trained model that we can now use to predict new instances that we are getting. So inside of our application, once again, we're now calling that model. We can take a look at the calculation. And we're simply telling it to score me. And what is returned is the probability that they are interested in each one of the terms. So 120 and all the products as well, fixed or variable. So this person is pretty much even between the two, whereas this person has a much higher likelihood of being interested in the fixed variable. So what we can do is now we can bring that into our offer table. Let's take a look at that. I can group by our application number to make it easier to read. But now here you can see that we've created an offer for each one of our terms as well as loan types. And then we can do all the economic information. So we can derive the rate. We're doing so through a rate table. Let's take a look at the rate table itself, and then let's take a look at the calculation. So we have a program table which has loan types. It has APRs for each one of the loan types and FICO bands. So the way this works is in the event that somebody is in between a 720 and an 850 FICO, and they are interested in a fixed 5-year term, this is what their rate would be. And it's subject to a couple different rules. So there's a minimum age, minimum credit history. So we'll use all this information in our program table to figure out whether people, number one, what their rate should be, what the economics of that offer will be, and then if they are approved or declined. So let's take a look at the calculation that's actually finding and extracting this information out. So here's the rate calculation. You'll see that it's referring to a program. So that program is right here. We're mapping to each one of these programs, and that's done through this calculation where we say, go into my programs and find the program that has a loan type equal to my current loan type, my term to my term, and then in between those two FICO bands. Now, you may be thinking that might get a little unwieldy and it's difficult to understand. Modelshop makes it easy to figure out some of this custom and, frankly, powerful logic through a dependency engine. So we can actually go and take a look at that calculation and look at all the variables that it depends on, and also everything that depends on it to really gain an understanding of how this is all coming together. So I can say, okay, this is based on the loan type. Now let's click through and try to gain an understanding of loan type. And we can traverse all the way through the model and check this out. So some really powerful tools for making sure that this is as easy and as understandable as possible. So what we do is once we've located the program by finding the FICO band and the relevant term, we extract out the APR, and then we can use built-in libraries that anybody who's used an Excel spreadsheet is familiar with. We have a finance to figure out the payments. Then we can go in and say, what is their current? And to do that, we can go into our application and get the student loan payments, which we've extracted from the credit score, or from, the credit report. Then we can figure out what their monthly savings is. We can determine how much we are extending or shaving off the term of the loan on average. And then we can call that predictor that we saw before, saying, hey, what is the chances that they are interested in this particular product? And we can use all that information to show them the right product for them. So then the final piece is, how do we go about decisioning these? And this person has been approved for everything here. But in the event, as we saw before, where someone were being declined, we could see some knockout rules here. So how are those knockout rules defined? We can open up the rule base that governs this offer table and take a look at that. And we have a couple simple rules that are going and being applied to each one of our offers. So let's take a look at a sample one. Here we're going into our application, we're getting the age, and then we're saying, is it less than the program minimum age, which you'll remember we saw from our program table. So the same way that we're extracting the rate out, we can get the minimum age from that program as well. And in the event that that rule fires as true, so the age is lower, then this rule would fire and that application would be declined. Okay, so I just want to touch on a couple different points. I know this has been a brief demo, but I do want to make a couple points that, number one, we're seeing this interactive dashboard here, and it's very useful. However, this is not the only way to interact with data inside of Modelshop. So everything that you've seen here so far can be exposed through a REST API. So I'm going to show you what that looks like right now. We're not limited to what we're seeing here. You can send new data in, you can query data, you can filter, you can do anything that you just saw from the UI through the APIs. But this means that it can very easily be integrated into other systems. It can be integrated into, say, a front-end web app or a downstream database. It's really up to you and totally flexible in that regard. Additionally, this integrates really well into enterprise applications and enterprise architectures. And some of the reasons why are we manage all of our dependencies on the fly. So it's really easy to audit and understand what's going on here. We show a mini version of this in terms of one of our calculations, but we can see the entire model in terms of dependencies here, and we can filter it all down to gain an understanding. Now, this should be really powerful, and the power should be easily understood by anybody who has, let's say, been handed a large Excel spreadsheet or a code base and has spent months trying to figure out what's going on in there. This makes it really easy to go in and say, hey, how is that rate being calculated? And now I can find it. I can find everything that it depends on, everything that depends on it. Additionally, we monitor all performance. So anything that's bogging down by having a particularly inefficient calculation, anybody who's dealt with an Excel spreadsheet that takes 10 seconds to save knows exactly what I'm talking about. We have a way of profiling these models to make sure that they are performant and we're not running into any bottlenecks. It's a pure Java application, so it's much more performant than let's say an Excel spreadsheet. But that's an example of the difference between Modelshop and some tools that are not meant for the enterprise. We really try to make sure that it's streamlined as possible. Lastly, every change that's made to the model, every configuration change is checked into source control. And you can go back and you can download old versions of the model so that you can kind of time travel back. Additionally, you can triage and see who changed what and when and what the effect was. And you can even revert back to old versions in case something went wrong and you need to get back to an older version. All right, I think I've covered everything. Thank you for joining me in this short demo of Modelshop. If there's anything that you have more questions on, we love doing in-depth demos and explanations, so feel free to reach out with any questions or comments. Thanks a lot.